Good morning, friends. Yesterday we have discussed about the spillway, its function, types of spillway, and the types of spillway and its application for different purposes. Now, today we shall discuss in more details about the ogee spillway or overfall spillway. Now, yesterday also we have discussed the two formulas. One is for computation of discharge Q over the spillway. The discharge Q is given as C into LE into HE raised to 3 by 2, where C is the coefficient of discharge. LE is the effective length of crest of spillway, and HE is the total head of flow on the crest of spillway. The effective length LE of the crest of overflow spillway is given by LE is equal to L dash minus 2 into bracket N into KP plus KA bracket complete into HE, where this L dash is the net length of the crest of the spillway, which is equal to the clear spans of the gate base between the piers. HE is the total head of the flow, which is equal to HD plus HA, where HD is the head over the crest of spillway and HA is the head due to velocity of approach flow. N is the number of piers provided over the spillway, which will be equal to the number of spans provided minus 1. Kp is the pier contraction coefficient and Ka is the abutment contraction coefficient. These depends on the shape of the nose of the pier and the shape of the abutment. Using the above equations, let us solve some numerical problems. The first problem. Let us note down the first problem. The data given for an ogee spillway is as follows. The point number 1, maximum level of water in the reservoir, that is maximum water level, is 252 meters. The bed level of the river is 230 meters. The maximum flood discharge is 5000 cubic or 5000 meter cube per second. Effective length of the spillway is 400 meters. Coefficient of discharge C is 2.1. Now you have to determine the reduced level of crest of spillway. Now from the above data, this as shown in the sketch, the bed level of the river, which is given as 230 meters, the crest of the spillway, the level of the crest of spillway is to be obtained. The maximum water level in the reservoir is given as 252 meters. And Q is the discharge, that is also given. Effective length of the spillway is also given. Therefore, using the formula for the discharge, Q is equal to C into LE into HE raised to 3 by 2. If we put the values of discharge C and LE, the HE is to be obtained. The head over the spillway, HE, which is obtained as 3.304 meters. Now, the maximum water level is given as 252 meters. Now, to obtain the crest of the spillway, subtract HE from the maximum water level to obtain the level of the crest of the spillway, which comes out to be 248.69 meters. Is it okay? Now, the second problem. Let us note down the second problem. An ogee spillway has 20 crest gates, each having 10 meter clear span. Find the maximum flood that can be safely passed by lifting all the gates when the maximum reservoir elevation is 110 meter and the crest level of the spillway is 106 meter. Assume the coefficient of discharge C as 2.16. The coefficient of end contraction for pier Kp is 0.05 and for abutment Ka is 0.1. Neglect the velocity of approach flow. Now from the data given for the ogee spillway, the maximum reservoir elevation is given as 110 meter. Crest level of the spillway is given as 106 meter. So from this maximum water level minus crest level, which is equal to 4 meter, which gives you the total head over the spillway, HE, which comes out to be 4 meter. Now, from the data given for the length of the spillway, calculate the effective length LE by the equation. LE is equal to L dash minus 2 into bracket N into Kp plus Ka into He. Now L dash, that is net length of the spillway, which will be equal to the number of spans, which is 20, into length of each span, which is equal to 200 meters. Now the number of piers N, as we have discussed, that will be equal to the number of spans minus 1, which comes out to be 19 numbers. Therefore, by putting the various values in the equation for effective length, the effective length of the spillway comes out to be 191.6 meters. Now, the discharge will be equal to, discharge Q will be equal to C into LE into HE raised to 3 by 2. C is given as 2.16. LE is calculated as 191.6 meters and the head over the spillway is given as 4 meters. Therefore, the discharge over the spillway comes out to be 3310.85 meter cube per seconds or cubic. The detailed hydraulic design of ogee or overflow spillway. Ogee shaft spillway is most commonly used spillway for the gravity dams, arch dams, and also earth and rockfill dams. The ogee spillway is an improvement over a free overfall spillway. The free overfall spillway is like if we have a small vertical wall or a weir and the flow over it, that is a overfall spillway. In this case, the water is flowing as a jet of water over the crest of the weir. Now, in case of an ogee spillway, the shape of the ogee spillway is like an elongated English letter S. Here, the head over the crest of the spillway, if it is HD, the water flowing over the ogee spillway, it glides over the downstream surface of the spillway. It smoothly glides over the downstream surface of the spillway. Now, the major difference between the free overfall spillway and the ogee spillway is that in overfall spillway, the water flowing over the crest of the spillway drops vertically as a free jet clear from the downstream face, whereas in case of ogee spillway, the water flowing over the crest is guided smoothly over the crest and is made to glide over the downstream face of spillway. As we have discussed, the ogee spillway has a control weir of ogee shaft, which is like a elongated English letter S. The shape of crest of the ogee spillway is made to conform closely to the profile of the lower surface of the nappy of a ventilated jet issuing from a sharp crested weir, when the head over the highest point of nappy is equal to the design head. The nappy-shaped profile is an ideal profile because at the design head, the water flowing over the crest of spillway always remains in contact with the surface of the spillway as it glides over it, and there will not be any negative pressure developed on the spillway face at the design head. Now, let us discuss about the design of the crest profile of ogee spillway. The shape of ogee spillway depends on the various factors. Number 1, head over the crest, that is HD. Number 2, the height of the spillway above the stream bed, P. The inclination of the upstream face of the spillway. Now in the sketch it is shown as vertical. It may be either inclined or vertical. So these factors will affect the shape of the ogee spillway. Now, USBR, that is United States Bureau of Reclamation, conducted extensive experimental studies to obtain the profile of the ogee spillway at this United States Waterway Experiment Station at Vicksburg, known as USWES. Now, according to USBR, the downstream profile of the spillway, is given by the equation x raised to n is equal to k into hd raised to n minus 1 into y, where x and y are the coordinates of the point on the spillway surface with origin at the highest point O of the crest, and HD is the design head, and K and N are the constants which depends on the inclination of upstream face of the spillway. Thus, for a vertical upstream face of the spillway, the constant K and N are given as K is equal to 2 and N is equal to 1.85. The upstream profile of the ogee spillway, as per the USBR experimental studies, which is in the form of a compound curve having two different radii R1 and R2. These radii R1 in terms of HD, design head HD, they are given as R1 is equal to 0.5 times HD and R2 is equal to 0.2 times HD. The distance A from the point O, that is crest of the spillway, for the first curve, that is given as 0.175 times HD, and the distance B of the end of the upstream profile, that is given as 0.28 times HD. Thus, using these equations, the upstream profile can be designed. Let us discuss about a numerical example on design of ogee spillway profile with the data given. Here, the height of the spillway crest above the river bed is given as 100 meter. The design discharge is 12,000 cumex. The number of spans of the spillway are 6. The clear distance between the piers, that is the length of or the width of the each span of the spillway, is 15 meter, the thickness of the piers in between, that is 3 meters. The slope of the downstream face of the overflow section is given as 0.8 horizontal to 1 vertical. This is the data given. Now, so from this data, we can obtain, as we have discussed in the earlier numerical example, the L dash, that is length of the spillway, which will be equal to length of the each span into number of spans, which comes out to be 90 meters. Now, assuming this L dash as the effective length of the spillway, also assuming the CD, that is coefficient of discharge, C, as 2.2, as the discharge, and from the given discharge, we will calculate the head HE over the spillway. So, which comes out to be HE is equal to 15.43 meters. Now, here the maximum value of CD is 2.2. However, it is affected by the various factors like height of the spillway, P by HD. In this case, P, height of the spillway, is given as 100 meters. HD, as we have calculated, is 15.43. So, P by HD comes out to be 6.48. So, as P by HD is greater than 2, the effect on CD is negligible. Also, the velocity of approach is small, as HD is equal to 15.43. The effect of actual head, if the design head is taken equal to actual head, HE upon HD ratio as 1, therefore there will not be any effect on CD. Now the effect of upstream slope. Now here upstream face is assumed to be vertical, hence there is no effect on CD. Now effect of downstream apron in this case, that is D plus HD, which is equal to 100 plus 15.43, that is 115.43 meter. Therefore, this HD plus D upon HD, which comes out to be 7.48. As this value is greater than 1.7, there is no effect on CD. Therefore, let us assume the CD is equal to 2.2 meter. Now, the end contraction coefficients Kp for piers is assumed to be 0.02, and for abutment K is assumed to be 0.2, which depends upon the shape of piers and abutments, as we have discussed earlier. So, using the above data, let us calculate the effective length of the spillway using the formula LE is equal to L dash minus 2 into N times Kp plus Ka bracket complete into HD. So putting L dash is equal to 90 meters, then N, the number of piers, which will be equal to 6 minus 1, that is 5. Kp is given as 0.02 and Ka 0.2 into HD, so which comes out to be 80.74 meters. Again, using the formula for the discharge and putting the new value of LE in this equation, which is 80.74 meters, and using CD is equal to 2.2 meters, the discharge as given 12,000 cumecs, calculate the new value of HE, which comes out to be 16.59 meters. Substituting the new value of HE in the equation for effective length, calculate the new value of LE again, which comes out to be 80.05 meters. And again, using the discharge equation, calculate HE, new value of HE, as 16.68 meter. Now, the design of the downstream profile. As the equation given by USBR, x raised to n is equal to k into hd raised to n minus 1 into y. Now, the velocity of approach flow, which can be calculated by using the continuity equation, q is equal to a into v. Thus, this discharge q, the cross-sectional area of the flow, which will be the length of the spillway, net length of the spillway, plus the number of piers into width of the pier into this height of the spillway plus the head. So which comes out to be 0.98 meter per seconds. Therefore, the head due to velocity of approach flow, which will be given by v square upon 2g, which comes out to be 0.05 meters. This being very small can be neglected. Therefore, small hd will be assumed to be equal to, approximately equal to h suffix capital D. Now, the upstream face of the spillway is assumed as vertical. Therefore, value of coefficient k in the above equation will be taken as 2 and n will be taken as 1.85. Now, putting these values in the equation for the downstream profile, let us put these values. We get this equation, y is equal to 0.0457 into x raised to 1.85. Now, the downstream face of overflow section, it is provided with a slope of 1 vertical to 0.8 horizontal. Therefore, dy by dx comes out to be 1.25. And dy by dx using the above equation comes out to be 1.85 into 0.0457 into x raised to 0.85, which is equal to, after simplification, it is 0.0845 into x raised to 0.85. Now, this is equated to the dy by dx 1.25, and value of x is calculated, which comes out to be 23.8.